Lesson 8.4, Angles of Elevation and Depression. The objective is to solve problems involving angles of elevation and depression. And your words are angle of elevation and angle of depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above that line. In our diagram at the bottom of the page, angle 1 is an angle of elevation from the tower T to the plane P. If you see, the men in the tower are looking up toward the plane, and we label this below the line right here. So it's labeled at that angle. An angle of depression is the angle that's formed by the horizontal line of sight. So his line of sight is here, and a point below. So this would be an angle of depression because the pilot is looking down at the men in the tower. Let's see if we can classify some of these. Let's look at angle 1 in our drawing. If we look at angle 1, we have a man standing here, we have a line of sight up here, but the horizontal that this goes with is above the tree. We also have labeled this above the line of sight. It's as though the top of the tree is looking down at the man. Therefore, this is an angle of depression. If we look at angle 4, right here, it goes from the line of sight here to the base of the tree. He's looking down at the base of the tree, and we've labeled it underneath. This is actually an angle of elevation then, because the tree base is looking up toward the man. The Space Needle casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? And we want to round this to the nearest meter. The first thing we want to do always is draw a sketch that represents the given information. We'll let A represent the tip of the shadow and B represent the top of the Space Needle. We'll let Y be the height of the Space Needle, like this. So we have A, the tip of the shadow it casts. B is the top of the needle. And we have a 70-degree angle here. Okay. And Y is how tall it is. We also know we're 67 meters here. So we're given the side adjacent to angle A, and Y is the opposite side, so we can write a tangent ratio because we have opposite and adjacent. So the tangent of 70 degrees equals Y over 67. If we multiply both sides by 67 to clear our fraction, we get Y equals 67 times the tangent of 70 degrees. At this point, we can just put this into our calculator, and we get that Y is about 184 meters tall. So the Space Needle is about 184 meters tall. Let's look at another one. An ice climber stands at the edge of a crevasse that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is this crevasse at this point? And we want to round to the nearest foot. First thing we want to do, of course, is draw a sketch. We need a pretty picture so that we see what we're looking for. Let's let C be the ice climber, and B will be the bottom of the opposite side, and Y will be the depth. Okay, so our climber is here, the bottom is here, the crevasse is 115 feet wide, and she's looking down at a 52-degree angle. And y is how deep the whole crevasse is. So if we use the alternate interior angles theorem, the measure of angle B is also 52 degrees. Let's look at that. We have two parallel lines. These are the alternate interior angles, and they have to be equal. Let's use a tangent ratio. The tangent of 52 degrees equals y, the whole depth of the crevasse, over its height, the adjacent side. Multiply both sides by 115 to clear our fraction, and we get that y equals 115 times the tangent of 52 degrees. Simplifying with the calculator, y is about 147 feet. Another application, a shipping application, an observer in a lighthouse is 69 feet above the water. He sights two boats in the water directly in front of him, and the angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. What is the distance between the two boats? And we want to round this to the nearest foot. Well, of course, first of all, we need a picture. So we have the lighthouse keeper up here, and the A and B are the two boats he sees. So the angle of depression to the farthest one is 22 degrees. The angle of depression to the nearest one is 48 degrees. He's 69 feet in the air, and we want to find x, the distance between the two boats. Okay? The whole side here is z, but we've broken it into y and x. So let's find y. By the alternate interior angles theorem, again, the measure of CAL is 58 degrees. In triangle ALC, the small first triangle, the tangent of 48 degrees equals 69 over y. So y equals 69 divided by the tangent of 48 degrees, which is about 62.1 feet. Then we want to find z, that whole side there, so that we can find x. And the reason we have to do this is because, as you see, this is not a right triangle. We can't just use a trig function to find x, because this is not a 90-degree angle. This is. So, by the alternate interior angles theorem, measure of CBL equals 22 degrees. In the triangle, the whole triangle, BLC, the tangent of 22 degrees equals 69 over z. So this would be about 170.8 feet. Then we find x. X is simply z minus y. So we take 170.8 and we subtract 62.1 from it, and we get about 109 feet. We say this is approximate because we've already rounded the other two numbers. The boats are about 109 feet apart. Now you try. The first section, you're classifying angles as angles of depression or elevation. And then you want to use the figure and classify again. For these, you want to classify, and then you want to solve problems.